the second one for this month, this special session again to get to learn something new and what you could take back to work. And today we've got another very key, where we have those sessions where we talk about things that are strategic that you need to be aware of. And today it is all about data retention, tactics for optimizing computing resources. And we already have the speaker live, so I'm going to put this in the chat. You can now follow us, be in much more integrated into the community beyond just these twice a month webinar sessions. We are now on multiple other platforms, and we try to want to keep the conversations going there. I'll share this, so no need of grabbing the screen. And now to our special guest, Ed Pollack. I have been honored to be in a session where he presented, and that's why, when he responded to our call for speaker for presentation, I was like, yeah, finally we are having him. And so he's a Microsoft MVP. He's someone who is passionate about sharing his knowledge, and he's written a lot of books. He also runs a community in Albany. I'm going to get the link. I know they're in person, but he's always happy that if people are able to come down there from here and, be part of the session. So I'm going to hand over to him so that I let him start on time while I try and chase off some of our regular members that, hey, why are they not yet in? So over to you, Ed, and I'll stop sharing my screen.
All right. Well, thank you very much for having me. This is a fun session because the initial reaction from a lot of people are like, how can you talk for an hour about this? But it's really easy. This is a big topic. It's a lot of fun, and a lot of the things aren't as intuitive or obvious as they might seem. So we're going to run on through. I'm going to keep the chat open and like one eye staring at it out of the corner like this, kind of. Not really like that. But if you happen to have any questions, feel free to put them in the chat, and I'll be happy to answer them, and we'll just kind of do it as we go along. I find saving them for the end is awkward because we forget things, or they get out of scope or whatever. So anyway, here I am. I will share this entire slide deck at the end, so no need to take pictures of everything or screenshots or whatever. I have published many books. I write articles. I organize a day of data in Albany coming up on August 8th. I will, what the heck, we'll drop a link in the chat for it. If you're interested in coming down to Albany for a day of data Albany, feel free. So here is a link in case you're interested. I've run SQL Saturday in New York City, which hopefully will occur in May of next year. We're working on it. It's in progress. Hope it happens. And I run the user group up here in Albany in case you ever want to come down here. We have a lot of fun. We have some good food usually. And we had an experiment with pizza that didn't go very well last month. But we have good food usually, and we have a lot of fun. So feel free to join us out here. It's a little far, but not too far. Let's dive right on in. This is really a presentation ultimately about savings and the data lifecycle. Those are really what this is all about more than anything else. The data lifecycle is really what guides everything we do in our profession. We don't think about it necessarily, but it's critical. Then I introduced the idea of retention, the benefits, which are huge, and then strategies, which are most of the presentation. The strategies go far beyond what we're used to talking about, what we're used to seeing. There's a lot of ways to manage data and make it go further. There's a lot of ways to save money, a lot of ways to save compute, and a lot of ways to make things faster and better. And it's not all by just deleting data. That's one way to look at it, but there are many, many others. And then part of this also is how do you sell this to people? Because when you tell anybody, I want to do stuff to your data, the most intuitive thing they'll say is, no, I don't want that. But how do we sell this? Because it's valuable. And I've been through this salesmanship before. Not necessarily easy, but once you get it going, it becomes a lot easier. And again, questions all along the way, but questions at the end too, if there's time. This is an example of a data lifecycle. It's not mine, but it's a data lifecycle. All data has a life cycle, whether you know it or not. In many organizations, the data lifecycle tends to be we create data and then it sits forever. But there can be many, many iterations of what happens to your data from the moment it's created to getting read, to getting written, to getting updated, to getting shipped somewhere by processes so it can get analyzed, dashboards, machine learning, AI, whatever. A lot happens with data. This is just an example of a data lifecycle, but if you don't recognize one for your data, it's worth talking about. So kind of backing up even one step from here, this is what we're familiar with. And so we build a system, and it works, and we have data. The data grows and grows and grows and grows. The number of arrows pointing at it, where data is getting loaded and people are waiting for data, selecting data, systems, processes, dashboards, reports, everyone's hitting this data, and eventually it gets to be a problem. There's simply too many processes, too much contention. The data got really big, it's getting slow, and we're running out of options. And there's always ways out. You can always add more compute, you can always add more indexes, you can always tweak the queries, you can always, there's a million things you can do to try to get out of trouble. But this presentation is all about one of the easier things to do, where it's simply savings. Like across the board, you can just save everything. Save compute, save money, save effort, save time. And that's why this is really elegant. It's a solution that not everyone considers, but it saves a lot of trouble. So number one, the first thing we have to do in the beginning of this journey here of the data lifecycle is that when we create data for the first time, when we architect a new table, when we build new data, we need to ask ourselves, what is that lifecycle going to look like? And will this data grow big? And if the answer is really yes to any of this, then you should have a data lifecycle for it. Obviously, some tables don't need it. If it's some lookup table with 10 rows, there's no lifecycle. If there's no created ons, last updated by, kind of things, then there's no lifecycle, and that's fine. Not everything needs this. We don't have to be monotonous and make every table complicated, every file complicated. But what we should do, though, is when we think something's going to grow over time, define a very basic life cycle. How long will it stick around for? Should we compress it? Should we move it somewhere else? How do people even use it? Do we need to keep it or not? And none of this is technical in nature, which is the key here. This is all business, really, in the end. It's decisions made by managers, executives, product managers, people like that. We don't usually make these decisions. We can make recommendations. We can say, hey, I look at a table, the data goes back to 2015. People are only using data for the past 3 months. So here's my recommendation. And you can do that, and that's good. But ultimately, a business should decide, what do we do with it? How do we change our data, get rid of it, move it, whatever. Doesn't need to be time consuming. And once you have a policy, once you begin creating data life cycles, it gets easier, much easier, because you'll see similar things come through. You'll already have policies from before. This isn't that big of a deal. It never needs to be complicated. It really doesn't. For most organizations, it's going to be very simple. It may simply be we write the data, and after a certain number of years, something happens. Done. It can be simple, or it can be complicated. It can be that circle with 8 steps. Again, it depends on what you need it for, and it'll probably change over time. You build something new now, it's small, you don't use it for much, and then one day in the far future, it's the center of all your reports. That happens. Retention periods can be defined as really anything based on the usage of the data. And I kind of classify data here, and it's useful to do so because temporary data is real. People do store a lot of temporary data in permanent tables and databases, but they don't always get rid of it. Sometimes we have a log table where after a week we don't care about the logs anymore. Or maybe they can just get shuttled off somewhere better where logs are supposed to go as opposed to a table. Temporary data can be intermediary data. It can be data that's put somewhere temporarily for processing purposes. TempDB is a great example in SQL Server of temporary data where you restart the server, it's all gone. And that's the perfect use case for temporary. From temporary, move to short-term, mid-term, and long-term, which really is how long do we keep data for? How long do we need it for? And once we don't need it anymore, what can we do with it? So defining that span is useful. Understanding how long data needs to be around for before it isn't relevant anymore, or it can get moved somewhere else. And forever data is real. When I say, do you really want this data forever, for the rest of eternity until we all die? People chuckle, but I'm being serious because some data is like that. There are going to be many, many places we store things where we want it forever, and forever is okay, as long as we define that up front and say, yes, I want it forever until death do you part, and maybe longer. So as long as we understand that, that's fine. But defining these things is useful. Understanding if we care or not about how long data sticks around helps us go further. And all of this ties directly to these key pieces of really all data management. That's RPO, RTO, and availability. I'm going to mention these throughout the evening. These are really, really important keys to how we manage data. RPO is recovery point objective. That is, in the event of a disaster, a legitimate disaster, how much data can be lost. And many times people are going to say, I don't want to lose any data. But the closer you get to no data loss, the more expensive it gets. RTO's recovery time objective. In the event of a disaster or emergency, how long will it take to fail over, restore backups, switch to the other node, whatever you're going to do? What will it take to get things back up again and working? How long? How much time will we be down for before it comes back up? And then availability is a more generic term for when is an application available. And this can be convenient for us. If an application needs to be up 24/7, it's got to be up 24/7, right? But if it can be up less, why not less? There is definitely a benefit if a app can go down in the evening or overnight or for an hour at midnight, things like that. That gives you flexibility for doing maintenance and processing and cleanup and compression and ETL and whatever other stuff you got to do. And so these three things pretty much are always a battle. The larger your data is, the more complex your data is, the harder it is to have good numbers for these, fast numbers for these. These are, again, business decisions. You don't decide this. A business decides it. You can make recommendations, but there's going to be a compromise where at first some executive is going to say, I don't want to lose any data. I don't want any downtime. Go. And you're going to say that it's going to cost a humongous amount of money. And they'll back off and say, well, I'm okay with a little bit of this, because the reality is that in almost any system, you can't avoid all downtime and you can't avoid all data loss. Is it possible? Sure. It's very expensive and few systems provide that, and you may or may not want that. So this ties back to what we discussed earlier and retention and the idea that the larger data is, the larger it is in terms of rows or size or files or whatever, the harder it's going to be to manage. The longer it takes to restore, the more data loss you'll incur if something happens, because bigger data takes longer to back up. It's just life, right? And if there's any kind of emergency, whatever recovery process you have simply going to take longer. And so you can always spend more money, you can make things faster, you can get more storage, you can have better availability systems, or we can manage data size. And again, many ways to manage data size, but this is kind of where we get into the meat of this. Like, what can we do to manage data size? And that's the fun part. The type of data will determine what we can do with it. How do we deal with data? And some questions we can ask ourselves are, is this internal or external data? Is it data that we use organizationally amongst ourselves that nobody on the outside sees? Or is this like customer user data? Like people log into your application every single day and see your data, and it's important. They see their data. They, are buying stuff on a website or things like that. They're banking, where it's their data and they have to access it all the time. That can help determine, your flexibility with it or when you can take actions on it. Log data is kind of special. We all have to keep log data. Log data is used for troubleshooting and reporting and posterity and many purposes, but very often log data is written and then left. And so log data you can tend to be more flexible with in terms of where it goes, how much you compress it, and where you store it. So log data is kind of special in that regard. You can do things like that with it. Temporary data is special in that it's here and gone. Therefore, have a process that makes sure that whatever that temporary is defined as, it's there, it's useful, it does what it has to do, and then it goes poof correctly. I've seen servers that have temporary data that's stuck around for years, and it's a lot of wasted resources. There's no reason for your cloud bill to go up like that for no reason. Nobody enjoys that. Transient data is also common if you're moving data around, ETL, ELT, data copying processes, things like that. You may have transient data that gets plopped somewhere temporarily, maybe staging data, reporting data, whatever. Again, that's data that's useful, it's important for a while, and then it stops being important later. But it needs to get from point A to point B somehow. So making sure it gets there along the way and doesn't leave breadcrumbs behind is important. If you accidentally leave stuff behind, that can cause trouble. I've seen this before. I've seen servers that have terabytes of files on them that should have nothing on them, but people just kept, oh, I'm getting an alert, the drive is full, let me just expand it. Whew, the alert went away, done. But nothing actually had to be there. But always a good question to ask as things get bigger and you see them getting bigger and bigger. Is everything in there actually useful? Do you need it all? Whether it's in a storage place, whether it's in Fabric or Azure, Managed Instance, SQL Server, whatever, just ask, as it gets bigger, should it? Is it getting big at the right rate? Is it getting way bigger than I expect? Or do I simply have a 5 GB database with a 1 TB log or just weird stuff like that? So check size, sanity check it to make sure it makes sense. And then posterity data is a lot of data out there. We keep stuff because we may need it one day. It might be very, very important for legal reasons, compliance reasons, auditing, or troubleshooting, perhaps. But that's posterity data where no one's going to touch it again unless they need it, and they're not going to need it very often. So we want it somewhere. It's got to be there, but we probably don't have to be super blazing fast, and it doesn't really matter how much we compress it. We just want it to be there. So these are kind of special types of data. You may have your own special types of data that have other conventions like this. They're just things to think about. Another great thing to consider is transactional versus analytic. What kind of data are we talking about? Because they really should both be stored very, very differently. And they often overlap. I get it. But if you separate them, it's great. Transactional data, that's the classic. I'm logging into an app, I'm placing orders, I'm withdrawing money, I'm posting something. Things are happening constantly, reading, writing, insert, update, delete, small numbers of rows, large numbers of columns. That is transactional stuff. And that's most of the data that we interact as users with on a daily basis. Teams right now, we're all using Teams as a transactional application. It's not analytic in nature. It's usually more time sensitive too, in that if I'm using an application and I'm interacting with data right now, it can't be slow. If I try to place an order and it takes more than 5 or 10 seconds, I quit. I'm gonna go somewhere else. You lost my business because I'm impatient. We're all impatient. Analytic data is all about reporting. It's about machine learning. It's about AI. It's about taking your data and crunching it and getting insights. And so typically, analytic data has more controlled load processes. So we don't insert, update, delete data all the time. Even if data is streaming in from the cloud or from the edge or from anywhere else, we can control it to some extent. And that control allows us to guide better how we write that data. We can take advantage of, bulk loading or compressed data or staging or, certain times where it's more convenient to load data, things like that. We tend to report on more rows, but less columns. Take a 2 million rows and sum up the quantity column but only return a few others, be done. And we can be a little more flexible, usually analytic data. If I'm running a report, it can probably take 1 or 2 more seconds and nobody's going to complain. Especially if it's something that's asynchronous, like the thing delivers to you. And very often, many reports and dashboards can be asynchronous. If I go into my phone and check out my health app, it doesn't have to be live. It's going through data for the past 6 months. It can have all that there waiting for me, already pre-crunched, ready to go. That's easy. So you can take a lot of conventions and conveniences to make the data easier to work with. Another key, and these are things that we have less control over in our personal, positions, and that is privacy and compliance. Are you required to retain or delete data after some period of time? You must keep data for 7 years. I must delete data after 3 years. If your contracts that you have with customers, those you can influence customer contracts. You can't change the law, not easily. But if you're a company or organization that has contracts with customers, those can be modified. You can't just do it, but you can work with other people to modify them if needed. I've seen contracts that had random fine print stuff in it about how long data is kept for, but no one actually cared. And when we changed it and told everyone we're changing it, nobody cared. And so there is flexibility there. You still have to make it official and make announcements and have your end user license agreement is changing kind of message, but you can still change them. Laws you can't change. Laws are there. They're the state, they're the government, they're countries, they're entities. You don't get a lot of leeway on those. Some examples here: GDPR, the European privacy laws; HIPAA, that's healthcare laws; COPPA, that's children's data protection. So there's many types of data out there that have laws that guide them. They change based on your country, where you live, what you deal with, the kind of data you have. If you're dealing with, medical data, you're going to have a lot more to deal with in terms of laws and compliance than if you're just dealing with cat photos and social media. So again, these are out of your control. Just be aware of whatever the law says you have to do with the data and follow those rules. If you're in a big organization, you have people in charge of it, like chief compliance officers. If not, maybe no big deal. And if you have any data agreements or other agreements, licensing things and user license agreements, just be aware of what they have in them. Those can change too potentially, but whatever you have, you got to know what they have. These may tell you what to do. You may have no say in the matter when it comes to how data gets dealt with. You may have some choices technically to make, but in terms of time frames, you may have no choice. But the rest of the presentation is all about strategies. Again, if you have any questions, feel free to put them in the chat. Keep an eye. But the rest of this presentation is all about strategies. What can we do to manage data once we have it and we know a little bit about it? These strategies are not all in a bubble. You can combine them. You can take different strategies, put them together, and ultimately we want these to align with everything that's going to be tied to this data. Compute, cost, performance. Performance is a biggie. What's fast for one app may not be fast for another, but usually performance is paramount. If your app is slow, if people are waiting, if they're frustrated, that's a problem. Business needs go beyond all of that. Whatever you think performance is good, ultimately the organization decides what is good. And if they think that a 1 second wait time is good for a click, then 1 second is good. And that's good enough. Keep it to that or less, right? And then compliance, of course. Compliance, you can't really help as much, but those guide you as well. And all these things put together kind of define what you can do with your data, and that gives you choices. The rest of this presentation is all about choices. The first and simplest, when you think of retention, this is what you think of, is deleting data. The simplest thing you can do. We can't always do it, but if you can, awesome. If you can say data older than a year, 3 years, 5 years, whatever can be deleted, awesome. It's the easiest thing you can do. And I put a little example here for fun, just to kind of show that, again, if you're deleting analytic data, especially in a column store world, just delete it. Make it go poof. You don't have to be careful about it. You can delete files, millions of rows, whatever at once. It'll be fine. If you're working with transactional data, you gotta be a little more careful because a ginormous delete will interrupt whatever stuff is going on. So just always remember, if you're working with transactional data, be a little cautious. And don't delete it all at once. You'll incur a giant transaction. It'll take a long time. It'll go to the log and make your log big. You'll have a giant log backup. You're digesting a giant hunk of food that wasn't meant to be swallowed in one piece, basically. So just do something like this, batch it, have your retention period. Make sure you index whatever retention column you have, especially if your data's big. Otherwise, you're going to say, delete all my older data, and it's going to scan the table over and over and take forever. And then someone's going to ask why your retention stinks. So just very, very simple example code, but just consider how you're going to delete data. Don't just hit delete. It may not perform well. Make sure that it occurs at a good time. It's not going to interrupt other people using the system, so on and so forth. If you can't delete it, that's fine. There's lots of data we can't delete. We need it. Maybe you can archive it. Archiving is kind of the next step. So we can't get rid of it. An app doesn't actually need it, but we might need it for something else. It may be needed for legal reasons, maybe needed for troubleshooting or posterity, or the compliance policy says I have to, the law says I have to. Archiving is kind of nice though, because I can take my data from where it is and move it somewhere else. The somewhere else can be cheaper, it can be slower. I can compress the heck out of it if I want to make it smaller and more efficient. Or it can be in the same place. You can have it in the same database, the same server. It can really go anywhere. Where it can go is up to you, what's available to you. If you're in the cloud, it could probably go anywhere on the universe. If not, you may have more limitations. Once you archive it, though, treat it more like analytic data, and therefore you can compress it a lot. You can page compress table data in SQL. You can change your compression algorithm in Parquet files or Delta Lake. You can go to the column store world and compress it even further. There's no reason not to. So just be aware that once your data is archived, you can compress it a lot more than you could when it's in the transactional world. And again, if you can't get people to agree on deleting data, this is a great next step. So if they're nervous about getting rid of it, if they think they might need it sometime, this is the next thing you offer them. You say, all right, fine. Like, we can't delete it, but how about this? How about we keep it for as long as you want? We'll just do some things that maybe we'll put in a separate table, separate file, separate database, separate server, separate something, I don't know, whatever. It goes somewhere else. And that somewhere else can be more cost effective, and equally important, it won't interfere with your production data processing that you already have. This is kind of a fun one too that I've used. It's another nice compromise. So we can't delete the data. Fine. I don't want to move it either. I like it where it is. Fine. How about this? maybe there's some large detail columns that are very space consuming that we can get rid of. So I have millions of rows of data. I have files full of data. But you know what? There's certain data elements, there are certain columns that are these giant description columns, the comments, the notes, they're huge binary columns, they're varchar maxes, they're file content, they're JSONs, they're XML. They are huge. I see the question over there. I'll grab that in a sec. These are huge data types. Maybe the organization will be okay if we keep the underlying data that describes the, who, what, when, why, how, but not the detail of it. So we'll keep the created time, the created by user, and all the other various minutiae that describes what this data is, where it came from, how it was made. But you know what? We can null out the big stuff. This is great. This can allow you to take data that takes up terabytes and turn it into gigabytes, and you still have like the granular rows that you need to describe what it was. You may not have detail anymore, but you have that description. You know what it was, when it was. You have a paper trail that can help you. This can be a nice strategy again if people don't want to delete data and they don't want to move the data. Maybe we can just do this. Maybe we can get rid of that, the big stuff, which will help us. There's a question here in the chat. The question is, how does deletion data happen in organizations? Is there a governance process where the deleted data has to be approved by multiple stakeholders? We have to add a buffer, mark data set for delete. So this is a lot of detailed question here about how do we manage data deletion in an organization. And the answer really, there's no one standard process. The answer is to have a process that you define, the organization defines, that you're comfortable with. Some organizations soft delete data and get rid of later. Some save it for longer, delete it sooner. It's really what your organization is comfortable with. In general, I push for as aggressive as they're willing to be and still be able to sleep at night. If they're okay with data being deleted after 3 years, I am too. That's great. If they prefer to archive it, I'm cool archiving it. Whatever buffers you put in there really are going to be what you need to be comfortable and the organization to be comfortable. That's all. And you have backups too. Don't forget we have backups. You can always take database backups as needed to have an additional, I take that once a month full backup. It goes, once a week full backup. It goes over there. We keep it for like years. There's those as options too. So you have many ways to kind of ease your way into retention in a way that will make your organization happy, that will make you comfortable, that will give you recovery pathways in case you need to restore that data later. I've seen it happen. You delete data, and a week later, someone says, "Can we get it back?" And ideally, you want some way back, not 5 years later, but maybe a week, a month, maybe a few months later. And there's a lot of ways to do that. So ultimately, if they don't know what they want, you can make recommendations. Just make sure that you maintain data for as long as you need. You don't want to be overly aggressive and take data away and then need it back immediately. You don't want to be backup, restore, backup, restore, backup. You don't want to be doing that. You don't want to be doing anyway. Everyone to be comfortable enough saying, like, if someone comes back for the data a year later, say, you know what, it's past your retention period. Sorry. And being comfortable with that. If people are comfortable with that, adjust your process. Again, this ultimately comes back to the data lifecycle and how is my data going to live from day one to the end of its life if it has one? Where does it go? So it is complicated potentially. Could be simple, but that's really a decision that has to get figured out. And sort of thing we're scheduling a meeting about. Let's all talk about the data lifecycle. How are we going to manage this? How long should we keep data around for? Hey, this is getting expensive. This is getting slow. Here's a way to make it faster. And very often cost is a great way to get people talking, if nothing else, or performance. Those two, really work. I've gotten a lot of traction in that over the years in ways I didn't think I would. Let's see. What else? Compression is a really easy retention strategy. Realistically, the older the data is, the less used, the less you write to it, the more you can compress it. If data is actively written constantly, insert, update, delete, you probably don't want to compress it. If it's inserted and deleted but not updated often, or it is inserted and deleted very often, might be able to take advantage of some low-level compression, like row compression, where you're not compressing too heavily, but it's helping you out a little bit. Let's get rid of all the extra zeros in your binary numbers, things like that. Page compression more aggressive, column store more aggressive. Parquet compression is way better than a text file or a CSV. So just consider the more analytic your data, the less it is written, the more you have leeway to compress it. That's a big deal. If you're in Delta Lake, Park, if you have storing data in Fabric, Synapse, things like that, by default, these files are already compressed. You can compress them more if you want. If you're stuck storing files in uncompressed formats, CSV, text, whatever, you can compress those files too once they aren't needed as much anymore. Or if they get transmitted, so if you just take a file and copy it somewhere, compress it before you copy it. There's no reason to keep a giant thing as you send it. It'll just make the transmission faster. But the general rule here is compression is wonderful. And the less you write data, the more you can compress it. The less you need it, the more you can compress it. The more analytic it is, the more you can compress it. It's that simple. And so don't be afraid to compress data. When it's not being written very often, it will save you all sorts of resources, not just storage, but memory. You read compressed data, you read it to memory compressed. Those pages stay compressed. You don't inflate that back up to its full size till you need it. And so that's very beneficial. So it saves storage, memory, that's compute, that's your storage bill, that's your cloud bill. That matters. We care about it. And kind of hand in hand with that, with bigger, older analytic type data is partitioning. I've used this as a strategy very, very often to manage larger tables. When I see a table get giant, I ask myself questions like, hey, can I split this table up and have like the active partition that people are really reading and writing heavily, and then all the rest of the data that people still read, they still care about, but they don't write it very often, and eventually it never gets written. Like probability wise, 99.9% of the data getting written is new, and then almost nobody ever writes the old data. So in cases like that, when your table gets giant, you can partition it, and you can have an uncompressed active partition, and you can have all the older partitions as compressed as heavily as you feel like. Doesn't matter. And this gives you a lot of flexibility on top of just the compression and shrinking it down, which is great. You can use all the partition functions to speed up moving data around. You can do all that partition magic, the partition truncation, splitting, merging, swapping partitions. Those are all cool tricks that can really move around data faster when you need to. And so if you have data that can take advantage of this, do it. It's wonderful. You need a process, of course, to manage this, whatever your partition structure is. Is it by month? Is it by year? Is it by something else, an ID? You got to manage that with some process. Ideally, you want to automate it. You don't want human beings doing the monthly clicking or whatever. You want a process that runs and just runs happily, only lets you know if it fails, which hopefully it never does. But partition elimination can even help performance. It's something you don't really bet on. You don't partition solely for the purpose of that, but I've seen enough scenarios where you take advantage of that because you have a billion rows of data. We're only really writing a few million. The rest can kind of sit, and that makes a big difference. Not having to read all the extra data, have all and you keep in mind that your index structures are kind of sort of logically separate by partition, so that helps a lot as well. It's just this is a great thing to consider when things get big, and you can partition, files in Fabric as well. There's partitioning pretty much everywhere. Your data gets giant, split it up. It's simple, it's straightforward, and once you've done it once or twice, you'll be very comfortable with it. And because this is technical in nature, it doesn't really impact the application. So you can partition tables and not actually change how the application accesses the data. So to a developer, that's awesome. To a software architect, it's awesome because your code doesn't change. And nothing makes a developer happier than not having to change their code. So that's bonus. Compression is the same way. I can compress my data. There's no need to change the application. The most common convention with all of this is the new and old data. So you have a table, new data pours in, we do tons of stuff with it, and then it kind of sits after that. And it sits and sits and sits forever. And people rarely go back to it, right? If you think about, your orders on a website like, Amazon, Target, Walmart, whatever, if you think about social media, how often do you go back to something from a month ago? Sort of often. You might go back to look at your old order from a month or a year ago to see what you ordered, but it's very rare you go back further. You might occasionally, but the number of times that I go in there and go back like 10 years to see what I ordered in 2016 is infrequent. And you'll notice too on most sites when you try to go back 10 years, it's really slow. Some do cool things to kind of help you with that. So they know you occasionally want old data, and they'll build processes to serve that up fast. Memories are a biggie. You can go on your phone. Here are your photo memories from the past, from all of the April 27th over time with your family. That's purposely served up data that you may be interested in so that you don't have to go searching for it later and accessing slow data. Same on social media, memories, classic. I want to see all the things that happened on this day in history going back forever. They can serve that up and cache it and make it readily available to you. Your songs in review for the year, that kind of stuff. And so those are all trickery, really, to make your old data fast. Ultimately, what you can do with the old data depends on flexibility. I've seen organizations split into two tables and say, you know what, our new data goes in this table, and then after a month or after a certain period of time or status passes, I can move the data somewhere else. Once a night we'll just process it and all the old data goes somewhere else. And then for reporting purposes, we'll union them together and have a view or something. And one of the benefits of separating out data by age when you can, if you can do it, is you can also manage them completely separately. You can index them separately. The really, really write-heavy table that is just concurrency hell, that can go like in memory or can minimally indexed for the fastest processing possible, uncompressed. Whereas the older data, the big, monstrous, giant stuff that everyone reports on after the fact and goes back to, that can be compressed and put somewhere else, indexed for searching. And so think about ways to separate them. Like you may not need constraints in the older data because you've already validated it all previously. Row store versus column store, read versus write heavy, analytics versus transactional. Just things to think about, new versus old data. How can I separate it? How can I structure it? How can I benefit the most from architecting some trickery into this to make things faster? There's a lot of data, but most of it is never touched anymore. And then this is again part of that. Eventually, all transactional data becomes analytic data. This is like the secret to life, is that all transactional data created in an app will eventually one day become analytic in nature. Either it sits for posterity and no one ever touches it, it sits and gets reported on, or it goes somewhere else for further reporting. Like, hey, we want to grab data from all of our customers and learn about their usage and about how our app is used and things like that. So we're going to pull that back and learn about it. And that's the little checkbox hiding in all of your apps that says collect metrics on usage, stuff like that. So again, think about data that isn't really written to anymore. Can we treat it like analytic data? Because the moment you can treat it like analytic data, I can take advantage of heavy compression, storage conventions, maybe slightly cheaper storage, right? Like your heavily accessed transaction data is critical, mission critical data. That goes into really expensive NVMe storage that's lightning fast and insanely expensive. But then once your data is sitting for a while, it doesn't need to be expensive anymore. It can be cheaper. Not slow, just cheaper. Maybe slow, but cheaper. So consider that. What can I do with it? Where can it go? Does it belong in a more analytic environment like a data lake or a data warehouse or some other star schema somewhere else, Snowflake schema, whatever? Like, where can I put it? So, or just a third-party analytics engine of your choice, Fabric or something like that. Where can I put my data? So, things to think about is once your data slowly transitions to being analytic in nature, I can treat it differently. And that's fun. I like that. There's lots of other options out there with what we can do with our data. Third-party apps are all over the place. People are happy to take your data and do stuff with it. They can store it for you. They can manage it for you. They can do all of the internal stuff that can make it faster, better, whatever. Obviously, third-party apps have benefits and drawbacks. The benefit is it's easy and you don't have to manage it. The drawback is vendor lock-in and the cost. It's $100 a month right now, and then next year it's $1,000 a month, and then it's $1,000,000 a month. But it still might be useful. And if you're already in a third-party product, already paying for a product already, there's no downside using it more. I'd rather personally use licensing for products I already have than license a new thing unless I have to. Hardware solutions exist to manage data as well. There's tons of hardware solutions that will store your data, that will dedupe it, that will compress it, that will do all kinds of cool trickery to make it faster. They're all over the place. And again, they're great products out there, but do you want to pay for them, manage them, store them? And if you're in the cloud, it may not even be relevant, hardware solutions. Data deduplication is a common thing done under the covers of software. Some products already do it for you, some do not. There's software solutions that will do it for you. If you have on-prem hardware, You can get hardware that does it for you. Essentially, all deduplication means is that it will find similar byte patterns, similar files, similar data, and basically summarize it. You have the same file in 20 places, so instead of storing it 20 times, we'll store it once and then have a pointer to it. And that's all automatic stuff, no code changes, but it does cost money. And if you decide you want to write the data over and over, it may take a little bit of time to write more data. So something to think about. There's also many hosted platforms out there as well. You can go into the cloud and use whatever your favorite hosted platform is for your data. People use all sorts of things. They use Tableau, Snowflake, Power BI, Fabric, Synapse. There's a million products out there. You can take your data, put it in the cloud, store it there, done. And if you use them already, great. If you don't, maybe it's the right choice. But there are many others as well. The strategies I provided here really were a combination of a lot of strategies. I can go back now and talk about how we took old data and did a whole lot more than just delete data. And that was really the key to this presentation, is that we're doing a lot more than just deleting. We can delete, but we can do a lot more, and that a lot more can really help us. One of the challenges we face, though, in all of this, in the end, is how do we sell this? One of the biggest challenges we have is how do you sell this process to anybody? Typically, the way this works is you go to a manager or an executive or someone and say, hey, this is getting really big. I think we could shrink it down. What can we do? And you'll say, like, can I delete older data? Can I move it? Can I compress it? And they'll be like, don't touch your old data. We need it forever. And you'll say, well, it costs money. And that's really where you begin to put in the debate, is you want to focus on cost and on performance and on things that have a tangible impact in the organization. That's how you convince people to make decisions. Every time in my life I proposed retention, I hit resistance immediately. The first time I did it, I hit tons of resistance. Do I really have to do this? Is there another way? Why do I want to do this? And then once you get past the initial resistance and show that we can do this, it's not painful, it's helpful, it gets easier. And the idea of retention becomes easier and easier and easier because it helps. It saves money, it saves performance, it can even improve security because older data, it can't be stolen. You get rid of it. If it's not in a readily available transactional environment, it's harder to get at. If it's off in posterity land, you can do more than just compress. You can encrypt it. You can make it hard to get at. And so in many ways, data retention can make data more secure as well. And so from the perspective of availability, performance, security, and cost, those are the sorts of arguments that people listen to. So if you're trying to convince people that retention is the right choice, that's the path you should go down first. And you can quantify it as well. If you need to quantify, you can quantify what's the cost of storage I would save, the cost of the memory, the I/O, the network bandwidth. What about those queries that run every day on the giant tables? Something that get really fast and that takes less, CPU. Can I suddenly have a server that is a little smaller instead of a little bigger? Can I save compute costs? Like, all of these are the ways that we sell this. So think about ways to sell retention that are creative, that use all of this. There's a lot of angles. And once you begin it, once you begin documenting it, I've documented it before. Here's our retention wiki page for the organization. Here's the document. It describes every single place where we have retention, what the retention period is, and the process done. And it doesn't change very often, which is nice. Occasionally retention periods may change, but the process rarely changes. You might get rid of it or add it, but it doesn't change often. So because of that, it's easy documentation to maintain, because you're not going to be going in and changing the retention period once a day. You could. That's crazy. Don't do that if you can help it. But more often than not, it won't change very often, which means it's easy to document. That's good. It's a good thing. Timing is important here as well. Data retention, all these things that we do take time. They involve usually manipulating data, deleting it, updating it, inserting it, moving it, compressing it. Even the partition stuff can take time if you have any data movement involved. Certainly moving around partitions is faster than moving around all the data, but there's still may data movement involved, and it may take a little bit of time and may cause a little bit of trouble. So treat retention like maintenance and try to schedule it at a time where you can tolerate that maintenance more. You can write it to happen midday. I've seen 24/7 apps where they're streaming data out of the app, deleting it, removing it every hour, every day. It happens, and it's just done in a way that it can happen and not interrupt people's work. But look at that though. Find the best time to do it because it's maintenance and it may have an impact on compute or on data access. If you have off hours times you can do things, awesome. You're lucky. Take advantage. If 10 p.m. to midnight is your magic time where you can do whatever you want and the app is quiet, enjoy. Have at it. And also avoid conflicts. Watch out for backups, reporting processes, and other things that happen in the background that may hit your data as well. Try to schedule the retention to not conflict with it. The last thing you want is, some analytic process goes in for reporting. At the same time, you go in for retention, you smash into each other, and something bad happens. It's slow. You get locking, blocking, deadlocking, contention, whatever. Just it's easy to avoid. Don't overlap other important processes that may require the data. One other thing to consider with retention is what do we do with related data? This may not matter to you, but if you have relational data and I want to delete sales data, that sales data has a create data. This is an example. There's lots of data out there, but let's say I have data that has things that hang off of it because it's relational in nature. I do see a question that just came up, and so I will answer some of these shortly at the end. Those are great questions. Thanks. I like that. Um, I have sales data. I have a create data on it. Awesome. I want to delete it, but whoa, I have sales notes that foreign key to it. I have documents that foreign key to it. I have support cases that key to it. I have business contacts related to it. Invoices that happen on that. What do you do with the related data? There's no one answer to this question. You can do whatever you want with this data, but decide ahead of time what you do with it. What do I do with the related data? Do I simply delete all that too? Maybe, but check though. Ask that question alongside when you're asking all the retention questions. Say, all right, we made a decision. We're good to go. These 5 things, these 6 things are related. Do I also delete it or should I save it and put it somewhere else? You may simply say, like, you know what? All this data can get trashed, but you know what? The business contacts, save those over there for posterity. We might need those in the future. That's fine. This is still great. Retention like that is still way better than no retention at all. So if there's relational data, just ask, what do we do with the dependent data? Make a definition and go with it. No big deal. This is not hard. It just requires consideration. That's all. And once you make your decisions, you're good to go. So I'm going to wrap up here and then hit the house questions and then answer any additional questions you come up with along the way as well. I made a whole presentation of this because we very rarely think about in the data architecture process the life cycle of data from start to end, from I create my data to it's done or it's in reporting world. Think about it. It's valuable. It's one of the first questions I ask when data gets created now is how long will it live for? How big will it get? And that can influence your architecture decisions too, up front. You'll make better decisions about how your data will get stored and accessed and queried if you know how it's going to live. This will help you improve performance. It'll save money. It can help with compliance. If compliance tells you to do things, do them, definitely. Reduce your data footprint. It's a natural win, makes things faster. And you don't even realize it, but you'll have better communication with your organization as a result of all this. When you're communicating with other teams, with product managers, with executives, other managers, other teams, telling them like, hey, here's how we manage our data. You helped decide this. Thank you. Now we're a big team and you're more familiar with the people in your org you may not talk to otherwise. So this is really valuable. And this is like a collaboration opportunity. It's a chance for leadership along that same line. This is a big deal. When we're in tech, we don't always get a lot of opportunities out of the box for leadership, for team building and leadership and collaboration. But these are ways to grow your career and make your job a lot more interesting than it is now, or certainly more interesting. If it's already more interesting, good. That's great. But many people find this as one of the many ways to collaborate and get involved in more teams and ultimately like take on leadership. This is one of the paths towards the future where I take a stake in something. I'm the person who's going to spearhead a project to solve this problem, And when I finish it, and now we have a retention process and a policy and retention of these 20 objects, that's awesome. That's your like accomplishment, and you did it with the help of other people. That's leadership. So that is awesome. And it's a way to like really expand yourself and have a little fun along the way too, and get out of the comfort zone. So I'm going to say thank you here. I will share this with you, and I am going to look to the questions now and begin to answer things. So I'm going to start here. Um, Someone's wondering here, do we write retention scripts and go to sleep during the off hours when it's scheduled to run, or do we stay up with them? And so the answer for that is, in an ideal world, if you have a retention process running after hours, you don't want to babysit it. Nobody does. Of course, the first time it runs, you might want to babysit it or have it maybe do a little bit of retention first. Instead of deleting a whole year of data, delete one day of data and see how it goes. And check for errors, check for exceptions, check for anything. Make sure it runs correctly. And then when you're happy with it, maybe run it for more. And so I definitely treat it like software. Treat your retention processes just like a software. And when you release software, you QA, you look out for bugs, you do all the things you would do with a software release. It's a great question. I like to treat all software like software. So data retention processes, their code, their software, treat it like software. Write it, review it, QA it, release it. And if it can go through all those processes like normal, you win. You're good. Have it run whenever you want. But make sure it goes through those processes so you feel like it actually got some rigor and you didn't simply write code, put it in production, and go to sleep, because that could be a little risky. I've done it. I don't recommend it. Not always the best idea unless it's low risk. But certainly for deleting important data, not sure if you want to just write it, go to sleep, and sleep well. If nothing else, I enjoy sleeping well at night. There were some house questions here. I'll check back for any more questions at the end. Career journey and story. I will briefly answer that question because I can go on for a while. I've been doing this for a while. My career began in hardware a long, long time ago. I worked with servers. I worked with help desk. I worked with, installations and hardware, and it was interesting. I enjoyed it. It was fun. I learned a lot about computers. And then one day, out of nowhere, a DBA like randomly quit, left, went to Mexico, vanished. Not quite sure what happened to them. Never heard from them again. Their social media is blank to this day. I check occasionally. It's fun. It's a fun part of the story. And I kind of took on some of the responsibilities. I had no idea what I was doing, but I realized quickly that I liked it. And that was kind of the beginning for me. Was I got into data. I knew I loved it. I wasn't very good at it yet, but I was going to spend a lot of time with it and figure it out. And that took me on the journey from like junior to mid-level to senior to I love performance optimization to I love building new things to wow, I can speak at a conference or write an article or do things I never knew I could do before. And then it kept growing and growing and growing. And that growth was a lot of fun for me. And I do encourage anybody here, if you have the opportunity to grow in ways, find ways to grow in your career. Speak at events, write things down, blog, volunteer at events, help organize events. There's always things going on. If you're in Toronto, there's tons going on there. You can always help out around. There's always a need for more. And when you speak at a user group, you don't have to be, internationally acclaimed rock star. Most user groups are happy for somebody local representing your area to speak and do something. So things to think about in the career journey, how to just do more if you want to. There's many ways to do it. Not all of it is precariously involved in speaking, but it can be fun. Book writing exploits. How do you balance writing about changing tech and not being too abstract? You find people read books. How do you overcome the stress and keep writing? It's not easy. I do have a second edition of my column store book coming out soon. Second editions are easier than first editions. Um, the first book I ever wrote really was a result of me being at a party, talking to somebody who I cared about and trusted a lot. And out of nowhere, they simply said, "Hey, you interested in writing? I've seen you writing articles before. You want to write a book?" And I said, "I've had a few drinks, yes." And that was the decision right there. And it was a good decision. The first book I ever wrote was very, very hard. I'd never done it before. All the conventions, all of the ways you do it, all of the rules you follow, every publisher has rules. It was hard. I wasn't used to the style, the third person you talk about things, not about yourself. It took a while to figure it out. it was hard, and it was also the exact same time that I was having my first kid. So I was trying to release the book faster than I released the child. I did succeed. That was good. Children like software releases, but they're more of a hardware release, I guess, and they're challenging. This was easier than that, probably. So definitely, this overcoming stress really is have a deadline far in the future and spread it out. It really works for me. Like if I have 12 chapters to write, I don't want to write 12 chapters in a week. I want to write one chapter every 4 days or 5 days for 3 or 4 months. Have enough buffer in your schedule so that it's not stressful, and don't procrastinate. If you procrastinate, you're making it stressful. And I personally can't do that. Some people do great under stress like that. I can't. I hate procrastinating. It makes me stressed. Some people are the opposite. If you are, go you. Awesome, no problem. But make your journey of what you create, whatever it is, mirror your how you work best, I guess, is what I did and what I recommend. Um, I have always loved the sequel. I kind of keep the questions going here. The original background was electrical engineering, and I never really got as into it as I thought I would. This was something I really found more interesting and more applicable to every field. I enjoyed hardware. I love learning about it. It still fascinates me to this day. I still play with it. But it comes back to this, honestly. I really enjoy working with data. It's something that applies to everything. I find data that's interesting out there all the time. I find working with it is fun. I find mistakes and follies everywhere, stories everywhere. It's just so big. The volume, the size, the vastness of it today, how it relates to everything too. Like I almost integrate into my daily lifestyle. I talk about data as part of my life. If I can't make a decision in my personal life, I will find data, I will collect data, and I will make a data-driven decision. I'm not beyond, as my wife and kids who are upstairs right now, probably, getting ready for bed, can tell you I'm not above having an Excel spreadsheet or a database in my personal life. They can help. So, I use it everywhere and I'm not shy about it. I'm a total geek about it and I love it. And it helps. And yes, baking. The last question mentions baking and carrot cake. Carrot cake is my favorite baked good. That's a great call out right there. I love baking. I've loved baking for a very, very long time. It's a hobby, not charging anybody for this. I don't have a business. This is a hobby. It's fun. When I travel to events, I'll occasionally bring bake stuff with me. If you come to my user group, I promise I will bake for you. It's just part of what I do. I bake every month. It's fun. Um, it's a hobby. To me, it's something that's very precise. It's an art, but it's precision. I enjoy it. I love sharing it. Makes people happy. So it's definitely something I do, and I post about it occasionally. I share it. It's enjoyable. So you know, hobbies are good. I definitely recommend everybody have hobbies. There's more to life than work. A hobby is something you do for fun. I highly recommend having them. Whatever it is you do, do it for fun. It'll make your life a little more enjoyable. So, if there are any more questions, feel free to submit them here. I can answer them now or find me later and I will answer them later. I'm going to post the link to this presentation on the GitHub, on the meetup for this event, linking over to GitHub. That way, if you want to download it, ask questions later, you're more than welcome to. And since we're trying to end on time here, I will hand it back to you, Michael.
Oh, thanks. Like, I'm glad I typed there because, I was not sure you would be able to go through them all, but it's great. I like the way you answered everything, and I would like to sneak in one more.
Sure, go for
Oh,
it.
wow, you still use the Microsoft Community and Event Tenant. They keep locking me out. I had to switch away all my webinars from that tenant to my regular tenant. But that's a conversation I can have with you on another day. I'm just surprised that you still use the tenant. Yeah. So the question I want to sneak in is, what's your professional response or how you beginning to include AI and how you think it's the right approach people should go with, using AI within the data sphere and what you do?
That's a big question, and that could probably be an entire presentation right now, very easily. My thought on AI is it's very powerful. It can do a lot. The few questions we have to ask is what is it best at, and what should it do? That's the beginning of it. And then what can it automate effectively, and how can you leverage smaller models to get it to do things more precisely. I find that people start out by throwing ChatGPT or Claude at problems, and they get answers, but like they're taking very, very big models and throwing them at very specific problems, and you have more of a room for error there. I find that define the problem, define what you're trying to solve, define the tool, make sure the tool matches the problem correctly, because there's a lot of AI algorithms out there, and within each algorithm, there are so many different sizes. Like, a lot of people are using Claude now. It's really common. Well, should I use the big one? Should I use Opus? Should I use a smaller one? What do I want to use? Do I want the bigger one or the smaller one? And small scale algorithms, small language models have huge use in the world. Like when you have a very specific problem you want to solve, I don't want the entire internet. I don't want a model that took 10 billion years to train. I want something targeted that hits the one thing I want. You know, it can be really great at certain things. Writing code, AI can be great at. Code reviewing can be great at. But there's many specific areas where it gets rough at. If I have a very advanced area I want to tap into, like, hey, I want to solve a parameter sniffing problem, or something, a performance issue, things that are very nuanced, may be more challenging. Again, this is a conversation that can become hours easily. So it's very hard to very quickly summarize when we should or shouldn't use AI, but that's kind of the beginning. I think of it as a tool, and all tools have good uses and bad uses, optimal uses and less optimal uses. Try to match the right tool for the job, and if you're not sure, call in help. I know that there's a strong desire to match up AI with everything, but finding the right tool for the job is key. And there's a lot of tools out there. AI has so many tools out there, and there's so many jobs as well. And you'll have different tools for different jobs, and that fundamental kind of helps us do the right thing, I think.
Okay, thanks. I would not want to keep you away from your family because I know it's late already. So I would say thank you very much. And to those who stayed till now, thank you very much. The session is being recorded. We're going to put the recording on our YouTube page later this week. But have a wonderful week ahead. And thank you, Ed, for the wonderful session.
Thank you
Thank you
very
very,
much
very
for having
much.
me tonight. I appreciate it, and I hope to see you soon.
Yeah, I'll try. I'll try to. It's every month, right? Like you said, the second Monday, or is the way you described the
Oh, so our user group in Albany, third Monday of the month,
third
Day of
Monday.
Data Albany, August 8th. Feel free to join us there as well. We have a fun event, I promise. Come on down to Albany, volunteer, speak, sponsor. The call for speakers is still open for 3 more days. So
Okay. I think
one
I'm
more
gonna
chance
come
to.
as attendee today to the
Sure,
regular one first. But thanks.
sure,
So
sure.
great. I'm ending the meeting now. It will take us out of the webinar
All right.
area.